Hello! Today we're going to be learning about the periodic table, atomic structure, and how to draw a Bohr-Rutherford diagram. So let's begin at the start. This is a periodic table. It has 118 elements on it, every element that we've ever discovered or made. Elements are the building blocks of the universe. They make everything around us. Each of those 118 building blocks has an element tile. This one is potassium. The element tile has the name, symbol, and a bit of information about the element. On this tile, the name is potassium, but the symbol is K. That's because K comes from the Latin word for potassium, which is kalium. But what are these numbers? What do they mean? Well, this top number is called the atomic number, and this bottom number is called the atomic mass. But what does that mean? To understand that, we're going to have to dive into atomic structure. This is an atom. Atoms are what make up elements. Atoms are so tiny that we can barely see them, even with the biggest, strongest microscopes. Atoms are made up of 3 subatomic particles: protons, neutrons, and electrons. Protons and neutrons live in the middle of the atom, or the nucleus. Protons have a positive charge, and they want to repel away from each other. However, neutrons don't have a charge. They are neutral, so they cannot repel or attract. However, neutrons are like superglue. They stick the protons together, so they cannot fly away. And electrons have a negative charge. They are attracted to the protons, but they repel from each other. That's why they orbit the nucleus. Protons and neutrons are around the same size, each are about 1 atomic unit. Electrons, though, are so small that we count them as 0 atomic units. Each subatomic particle also has an important role. The electrons interact with other atoms and elements, the neutrons keep the protons together and the electrons away, and the protons identify the atom. Each element has a different number of protons. This brings us back to the element tile. The atomic number is the number of protons in an atom of this element. For example, potassium has 19 protons. And the atomic mass is the mass of the atom, so the mass of the protons and neutrons. The electrons are too small to count. And now this is really cool. We can use the atomic mass and number to find out how many neutrons there are in any given element. Because protons are equal to 1 atomic unit, however many protons there are, that's as many atomic units as it weighs. So we can take the number of protons, or the atomic number, away from the atomic mass to get the number of neutrons, because neutrons, also being 1 atomic unit, have the same number of themselves as they weigh. So let's use this strategy to figure out how many neutrons there are in potassium. Potassium has an atomic mass of 39, so we'll write 39 here at the top. Potassium also has 19 protons, which each weigh 1 atomic unit, so we take 19 atomic units away from 39 atomic units. We're going to get 20 atomic units, which also is the number of neutrons. So with this information, we can determine that a potassium atom would look like this. But this is kind of messy to look at. There's so many protons and neutrons. This is where the Bohr-Rutherford diagram becomes so incredibly helpful. It's a simplified way to look at an atom and all of its subatomic particles. So let's learn how to draw one. First, I'll start with a fresh piece of paper. So first, let's start with the nucleus. Instead of drawing 20 neutrons and 19 protons, like we know potassium has, we're simply going to draw a big circle and write inside that there are 19 positive protons and 20 neutral neutrons. Next are the electrons, and this is where things actually get complicated. Firstly, we know that since each element has a different number of protons, they also each have a different number of electrons. This is important. See, electrons don't just randomly float around an atom, they actually have designated spaces. These are called energy paths, or energy levels. And this is how we indicate those energy levels on a Bohr-Rutherford diagram. The first energy path can have a maximum of 2 electrons, so hydrogen and helium both only have one energy path. But if an element has more than 2 electrons, we move to the second path, which can have up to 8 electrons. If an element has more, we move on to the next path, which can also hold 8, along with each path after that. So potassium has 19 electrons, and so you can see that we filled up the first 3 paths. And the last electron goes on the final path, the outside path. Now this is called a valence electron. Any electrons in any element that go on the outermost path are called valence electrons. Valence electrons are incredibly important when it comes to the organization of the periodic table. The periodic table is organized in rows and families. Rows each have the same number of energy paths, but varying numbers of valence electrons. Periods or families have the same number of valence electrons, but varying numbers of energy levels. So that's why valence electrons and energy levels are so important to the periodic table. Potassium, as we can see by our Bohr-Rutherford diagram, is part of period 1 on the periodic table, because it only has 1 valence electron. However, it is part of the 4th row, because it has 4 energy paths or levels. Cool, right? So there you go. Now you can read the periodic table and understand how it's organized, understand atomic structure, and draw a Bohr-Rutherford diagram. Good job, and thank you for letting me teach you how to do all these things.